Hey, please don't resist learning about resistance, okay? Yes, this is going to be part of a four-part series on the basics of circuits, and this first one is going to be about resistance, okay? Resistance. Why is it called resistance? Because physicists are not very creative people. They call it resistance because it resists something. What does it resist? It resists electrical current. So resistance resists electric current. Our next little series is going to be about electric current, so don't fret about that. But the symbol for resistance, just so you have it, is a capital R. Okay. The unit for resistance is an ohm, which is going to be this Greek symbol omega. Okay. And then what you do have to be careful is a resistor. What is a resistor? Well, a resistor is typically what is using the electrical current's energy, the charge's energy. That could be a motor, it could be a light bulb, it could be a heater, it could be a stereo, it could be whatever. It's what is using the electrical energy from the charges that are moving. That's a resistor. Now, resistance relates to something called resistivity. Okay? Resistivity is not the same thing as resistance. Resistivity is, a fundamental property of matter, of the substance. And the substance, each substance is going to have a certain property that, like, it wants to resist the flow of charge, or it doesn't want to resist the flow of charge. Resistivity is a property of the substance. And it's sort of a number that tells you how good or bad a resistor something is, or how good or bad a conductor something is. For example, okay, the symbol for resistivity is a Greek symbol rho, okay, and the units for resistivity are ohms times meter, which we'll talk about why that is in a minute. But the resistivity of, for example, copper is 1.68 times 10 to the minus 8th ohms times meter, where the resistivity of gold is 2.44 times 10 to the minus 8th ohms times meter, and the resistivity of rubber is, I believe, 10 to the 13th. Let me just look it up. 10 to the 13th, yes. 10 to the 13th ohms times meter. So let's talk about what this means. Well, this tells you that copper and gold are really pretty darn good conductors. They are not very good resistors because you can see that the resistivity is ridiculously small, okay, where rubber is a very good resistor. It is a really good insulator, 10 to the 13th ohm times meter, because it really is hard for charges to flow through it. But between copper and gold, you can see actually copper is a little bit better conductor. Why? Because it has a little bit smaller resistivity. Okay. Now the formula that relates this is R equals rho L over A. If you look on your formula sheet, and I would, that is there. Okay, so let's talk about what this actually means. The resistance of a substance, okay, of a material, depends on its resistivity, like what is the material made out of, the length of the material, and then the cross-sectional area. So this is where you have to be careful. If you have a normal wire is typically a tube, okay? Well, it's probably not a really big tube, but how do you find the cross-sectional area of that? Oh, well, that would be pi r squared. So if they tell you the thickness of the wire, that's not r. That's not a. You would have to take that thickness, divide by 2, that's r, and then do pi r squared. If you had a wire that's more of a kind of a rectangular thing, it's something like this, then the area, the cross-sectional area of this would just be base times height. You have to kind of use your brain and think about things, okay? Where the length would be the actual length of the wire, or the length of this, whatever this thing is, this thing, okay? So that's that. Now you have to be careful, and you have to be able to use this formula and think about stuff with graphs. You know, if you see a graph like this, well, hey, look, R is proportional to L. Oh, that's going to be a line. Oh, the slope of that line is R over L. Well, hey, look, if I do some really intense algebra here, and I rearrange this, oh, that means this is going to be equal to rho over A. Okay, you guys need to be able to do that basic algebra. You know, if I had this instead, if I said, hey, I'm going to graph R versus A. Well, hey, look, R is proportional to 1 over A. Oh, what is that? That's an inverse graph. Oh, that's this graph. Oh, if I wanted to linearize it, I would have to graph 1 over A. And then that would be a line. And then what would the slope tell me? Well, my slope would be R over, actually it would be R times A, because it would be R over 1 over A, which is R times A. Well, if you look, R times A, oh, that would be rho times L. Yeah, you're expected to be able to do that basic stuff, okay? That's my first video on resistance. I hope that makes sense. Bye, kids.